Find the radius of the small inscribed circle and the circumference of the circumscribed circle. Draw the inscribed rectangle completely. Since the sides of the rectangle is tangent to the small inscribed circle, the radius, r of the circle, is perpendicular to these sides of the rectangle. It formed two congruent squares, as shown on the screen. The combined side lengths of the two congruent squares equals the diameter of the small inscribed circle, which equals to 8 units. If d is the diameter of the inscribed circle, then d equals 2 times r, which equals to 8. Divide the equation by 2. It implies that r equals half of 8, which equals to 4 units. Therefore, the radius, r of the inscribed circle equals 4 units. Solution to question 2. Label B, O, E, and D. O is the center of the circumscribed circle. Let R be its radius. It follows that line B, E equals 2 times R, which equals to 8, and line B, O equals R, the radius of the circumscribed circle. It implies that line O, E equals line B, E minus line B, O, which equals 8 minus R, as shown on the screen. Join line O, D, which equals to R. Consider right triangle DOE. Use Pythagora's theorem. The square of line OD equals the sum of the square of line OE and the square of line ED. Substitute values. We have that the square of r equals the sum of the square of 8 minus r and the square of 4. Expand bracket. As shown on the screen. Simplify and combine like terms. 16 times r equals the sum of 64 and the square of 4, which equals to 80. Divide the equation by 16. R equals 80 divided by 16, which equals to 5. This implies that R equals 5 units. Therefore, the circumference of the circumscribed circle, C equals 2 times the product of pi and R, which equals to 10 times pi in units. After simplification of substituted values.